inside and outside test. Now, as I told you, what is inside test? As the name suggests, it is also called as inside or outside test. Now, what it tells that whether a particular pixel is inside of the polygon or not. So you are going to check this thing. Okay. Now, why do we need to check this? Because in this unit, we are going to fill the particular polygon with a color. Okay. As we have started with drawing a pixel, then we have started with drawing a line, then we have drawn a polygon, and now when the polygon is drawn, I want to fill it with some color. Okay. Now, I told you that in a paintbrush, you draw one rectangle. Okay. Now, if I tell you to color that polygon with say yellow color, what you do, you pick up the fill tool and you click inside of that particular rectangle. Okay. And then only that rectangle gets filled with the selected color. Okay. But what you do, if you click outside of that particular polygon, the background color is filled with the yellow color. So what you need to do, you have to click inside of the polygon. So same concept we are going to use here. Here we don't have any ready-made tools. Okay. So what we have to do is we have to identify a particular pixel which is surely inside of the polygon. Okay. So how to identify that? We have inside and outside test for that. Okay. So to identify whether a point is inside or outside of the polygon, we have now two methods, and that method is called as even odd method and winding number method. So we will see each method in detail now. We had again started with the even odd method. Now, as the name suggests, we have to count the number of intersections, and if it is even, then point may be inside or outside, so that we will see here. Okay. So even odd method, what we have to do is, you have a particular polygon over here, right? And you have to identify. So if you look at this figure, there is pixel 1, pixel 2, and pixel 3. So we have to identify whether these pixels 1, 2, 3 are inside of the polygon or outside of the polygon. Now, if you look at the figure directly, you can say that yes, points 1 and 3 are inside of the polygon and point 2 is outside of the polygon. Okay, but how does the computer understand this? So that's why we have to use these methods, right? So consider the pixel 1 that you want to identify whether it is inside or outside. So what we need to do is we have to draw a scan line. Okay, so draw a line from any position P. So this is the position P or pixel 1 to a distant point which is outside the coordinate extents. So for this polygon, coordinate extents are what? This is the extent coordinate, AE or CD. So this is the leftmost extent. So we will draw line from this one. So scan line S1, S2, S3 are the three scan lines we have drawn up to that particular pixel. So S1 to pixel 1, we have drawn one scan line. Okay. Now what we have to do is count the number of edge crossings along the scan line. So we have to check whether this scan line is crossing any of the edges. So here it has crossed one edge only, and that edge is AE. Okay. So now what we need to do is count the number of intersections. So if the number of intersections of the scan line with the polygon edges is, if it is odd, then the point in question is interior or inside of the polygon. If it is odd number of intersections odd, then the point is inside of the polygon. And if the number of intersections are even, then the point in question is outside of the polygon. Okay. Now we will check each of the line here. Here pixel 1 we are checking. We have drawn one line up to that pixel only. Okay. Now this scan line 1, it is crossing only one edge at this particular point. I'll take a pen. So here it has crossed, okay, or intersected. So number of intersections for this S1 line are only 1. Okay. So one number is whether it is odd or even. So 1 is odd. One number is odd. And if the number of intersections are odd, we can say that the point in question, this point 1, is inside of the polygon. Okay. So we have concluded that point 1 is inside of the polygon. Now we have to check for the second pixel. Suppose this is the question that identify whether the pixel 2 is inside or outside of the polygon. What is the procedure that we need to follow? We will draw one scan line outside of this polygon up to that pixel. So S2 I have drawn from here to this pixel 2. Again, what we have to do? Find out the number of intersections with the polygon edges. How many edges it has crossed? Only 2 edges, that is edge AE and edge CD at this particular point. So here one first intersection is there and here it is second intersection is there. Okay. So how many number of intersections are there? There are 2 intersections and number 2 is odd or even. So this is even number. And if the number of intersections are even, then we can say the point in question is outside of the polygon, right? So this is outside of the polygon. Again, we will check one more pixel, pixel 3. Now here, by looking at this, we can easily identify that yes, it is inside of the polygon, but we have to calculate it with the even odd method. Again, we will draw one scan line, this S3. Now this scan line is intersecting 3 polygon edges, that is AE, then AB, and then BC at these locations, 1, 2, and 3. So number of intersections are 3. 3 is the odd number, and if it is odd, we can say that the pixel is inside of the polygon, and that's why this pixel is inside of the polygon. Okay, have you understood all up to this?
Yes, ma'am.
Okay, very good. Now we will proceed further that in case of even odd method, we have to consider some of the special cases. Okay, this is very important question from the exam point of view. Okay, so you can note down this, that if the number of intersections are odd, then it is inside of the polygon, and if the number of intersections are even, then it is outside of the polygon. And you can draw this diagram also just for understanding. Okay, so we will move further, that we have to consider some of the special cases for identifying inside and outside test. Now, what is that special case? If a scan line crosses through a vertex. Okay, I'll just take a pen here. Now, what will happen if the scan line is crossing through a vertex? We will see this with example itself. Consider first figure A polygon. Okay. Now, how many vertices are there in this figure? Vertex A, B, C, D, E, F, and G. So 7 vertices are there for this figure A. And for figure B, there are A, B, C, D, E, and F. So 6 vertices are there. Okay. Now, again, we have to find out whether the pixel is inside or not. So here, this is the first question, that is pixel 1, and this is second question, that is pixel 2. So we have to identify. Now, suppose if I want to identify pixel for pixel 1, whether it is inside or not, what is my procedure? I will again draw one scan line S1 up to pixel 1. Okay. Now, while drawing this scan line, my scan line is passing through this particular vertex C. Okay, just check out here. This is the vertex C, and scan line is passing exactly through this vertex, and it is then going to the pixel 1. Okay, now again the same procedure I have to follow, that when we draw a scan line, we need to find out the number of intersections with the polygon edges. But in this case, when scan line passes through the vertex, exactly through the vertex, what will be the count of this intersection? Okay, whether you will consider this intersection as 1 or 2. So there is a rule for this. Okay, what is that rule? You can note down these rules. If a scan line passes through a vertex having two intersecting edges, then if both the edges lie on the same side, this is important, same side of the scan line, then the intersection is considered to be even. That is, you have to consider their number of intersections as 2. So what is this case? I will tell you in detail. Okay, so what we have done, we have drawn a scan line up to the pixel 1. My scan line is intersecting the vertex C. Okay, now if it is a vertex, definitely it is connecting two edges. So which two edges this vertex C is connecting? Edge BC and edge DC. Okay, so for both of these edges, this vertex C is common. Okay, now what is the rule? Rule says that if both those edges lie on the same side of the scan line, see here, this is your scan line. Okay, and both of these two edges BC and CD, these two edges are lying on the same side, that is on upper side of the scan line. So both of these edges are on the same side. If these two edges are on the same side, then you have to consider the number of intersections as 2. Here, the rule is saying that it should be considered as 2. So how many intersections will be there now? Can anybody tell me? For pixel 1, how many intersections are there with the polygon edges? Total number of intersections are
2.
3.
total intersections are 3.
4.
4.
No, for pixel 1 I'm saying. If you want to find out pixel 1, you will draw a scan line up to pixel 1 only, right? And then you will count the number of intersections. So first intersection is where it is with the line AG. So this is, I'm crossing the intersections, okay? So this is my first intersection. Second intersection is at this vertex C. So here again cross. But how many intersections you will count here? As this line and this line, both are lying on the same side of this scan line. So here number of intersections should be considered as even, that is 2. So here intersection is 1, here the intersections are 2. So how many total number of intersections are? 3. Okay. So for pixel 1, total number of intersections are 3. Again, the same rule will follow that if the number of intersections are odd, then the point in question is inside of the polygon. And this 2 plus 1, that is 3. 3 is odd. So we can say that pixel 1 is inside of the polygon. Okay. Now go for pixel 2. So I'll just erase all these things. I will erase all this part. Now we will consider the pixel 2 here. Okay. So pixel 2 means what now? Again, what you have to do? You have to draw a scan line up to pixel 2. Okay. Again, you have to find out the number of intersections. Again, this scan line is crossing the vertex C. Okay. So here, first intersection is at edge AG. So this is your first intersection. Here again at vertex C, and both these lines are lying on the same side. So number of intersections will be 2. Here, this line is crossing one more edge, that is edge EF. So here one more intersection is there. So here intersection is 1. So you have to add these intersections. 1 plus 2 plus 1, that is 4. And number 4 is even number. Okay, and that's why we can say that it is outside of the polygon, and we can clearly see that pixel 2 is outside of the polygon. So this is the first special case. Now one more special case is there. You consider this figure B. Okay, here different type of polygon is there. Okay, now I want to find out for pixel, first consider pixel 1. Okay, this is the pixel that I want to find out. What is my normal procedure? I will draw one scan line up to pixel 1. How many number of intersections are there? 1 intersection. But here, again, this type of intersection, it is again a vertex. What is that vertex? F. It is crossing the vertex F. But in this case, This F vertex is common for which edges? Edge AF and edge EF. Okay, so these are the two edges for which this vertex F is common. But now in this case, both of these edges AF and EF are lying on different side of the scan line. Here, for this particular vertex C, both these edges are lying on the same side of the scan line. But here, I have drawn this scan line and edge AF and edge EF are on different sides of the scan line. Okay, so in this case, you have to consider this intersection as one only. Here we were considering the intersection as two because both these edges were on the same side of the scan line. Here, both the edges are on different side of the scan line. So we have to consider this intersection as one only. And here is the point. Okay, so here you will count the number of intersections as one. One is odd number, and that's why point 1 is inside of the polygon. Similarly, now we will check for pixel 2. Are you getting this? Now go for pixel 2. You will tell me the answer now. For pixel 2, how many number of intersections are there? So what you have to do is, you have to consider this pixel. What you will do? You will draw one scan line, okay, up to pixel 2. Scan line is crossing how many edges? 3 edges, okay, or 2 edges you can say. One, it is crossing this BC, and one, it is crossing a vertex, okay. But in this case, this vertex, both the lines, this line and this line, are on different side of this scan line. So number of intersections will be 1 here. Again, this edge BC, here is one intersection. So this is the normal edge only. So we can consider this intersection as 1. Add these intersections. So 1 plus 1, that is 2. So total number of intersections are 2. 2 is the even number. And if it is even, the point in question, that is pixel 2, is outside of the polygon.